In this problem, we're given a trough with this as its width, this as its length, and this as its height. And if you wanted to find the total volume of the trough, you could multiply those three dimensions and cut it in half. You're likely not here for that part of the video, so I am going to make that quick. Plugging the dimensions 12, 7, and 6 into the formula, you'd get 1/2 times 12 times 7 times 6. Since the three dimensions are being multiplied, I didn't pay attention to the order that I typed them in. The volume of the trough would be 252, and since the units on each of the dimensions were given in feet, you'd have the width in feet, the height in feet, and the length in feet. Multiplying feet together 3 times would give you feet cubed, or cubic feet, which I'll denote like this. The second part of the video takes a little bit more work. It says find the volume of the water in the trough if the water level was not 6 feet, as in the last part of the question, but if it was only 4 feet high. So we'd still use the same formula for volume, 1/2 width, height, and length. The length is always 12 feet long, and they're giving us that the height is 4 feet. So the only thing left to find would be the width of, say, a smaller trough, where the water level is only this high right here, with a height of 4 feet, compared to if the trough were full, the height was given to be 6 feet of water. So what I'm going to do is use similar triangles and compare this big triangle here, which would be if the trough were full. Let me make a copy of that. And then let's compare that with the smaller triangle you'd get now that the trough is only 4 feet high of water. Let me make a copy of that. These two triangles should be similar, so I can just set up a proportion, maybe comparing the width to the height of the big triangle as compared to the width and the height of the smaller triangle. It was given in the problem that the trough, when full, has a width of 7. That was right here. It was 7 feet wide. And we were given that the trough originally had 6 feet of water, and so the height was 6. In the smaller triangle, we don't know the width. That's what we're trying to find, so we can plug it into the overall equation to find this volume. But we are given that the water is 4 feet in height, so H would be 4. So what I'm going to do is set up a proportion that the width of the large triangle, call it triangle number 1, divided by the height of the large triangle, would be in proportion to the width of the smaller triangle, call that W sub 2, over the height of the smaller triangle, call that height sub 2. So plugging these numbers in, I have that width divided by height on the big triangle would be 7 divided by 6. And I'm saying that will be equal to the width divided by the height of the smaller triangle, which I'm just going to call W over 4. Now I'm going to multiply the 4 on both sides of the equation and the 6 at the same time. So I will get 7 times 4 is equal to 6 times W. Some people refer to this as cross multiplication, where you draw these little arrows. And that's fine if you want to think of it that way, as long as you realize that the context of using cross multiplication has to be in this exact structure where you have fractions A over B equals C over D. Any other kind of structure besides that, this would not work. So we have 7 times 4 is 28, is equal to 6W. So I'm getting the width is 28 over 6 feet. So I'm going to put that right here. Again, you're multiplying feet by feet by feet, so that'll give us cubic feet, or feet raised to the 3rd power. Now it's just a matter of going on the calculator and multiplying these 4 numbers. 1/2. I'm just going to use parentheses for the fraction 28/6, and then multiplying by 4 and 12. I get that the volume of the water, if the trough was only 4 feet high, that would be this amount of water here, comes out to be 112 cubic feet. So hopefully that made sense, and I'll end the video there.